Okay, hello everyone. I think we're live. Um, yes, I think we are. Hello and welcome everyone to another day, another stream, where we build game engine in Go from mostly scratch. We try to hopefully make it good, performant. Now, last time, what we did, let me get the git log here. So we close this, zoom in so everyone can see. So, what we did was, let's see, on last stream, is we did the game loop, right? And we abstracted away IMGUI. So that was a really good step. And we finally can actually, one second, let me open up chat. Yep, we're live, all right. Okay. So we did that and we abstracted IMGUI. We made a small struct to handle our game, like just to test. But since then, I did some things offline I'd like to discuss before we go on. And we'll see. I'm not sure what we'll do today, but I guess we'll see. One thing is, the loading of PNGs were wrong. It was flipped. So our textures were uploaded to the GPU flipped, and it didn't match with what we actually saw in the editor in Blender. So let me talk about why, and then we'll see the fix. Like, the fix is pretty simple. So if we look at OpenGL texture coordinates, yeah. So as you can see, 0, 0 is bottom left of the image. So if you have like a triangle like this, 0, 0 is your bottom left. Thing is, when we get the bytes right now from Go, we get them top left. So 0, 0 is top left. So the x-axis is correct, the y-axis is flipped. And instead of going bottom up, it's sending the texture top to bottom. So the results look flipped, essentially. So what we need to do is instead start reading from the end of it, right? From the last y position and read up. The x is fine. We go left, right, left to the right. That's okay. But we need to go bottom to the top. That's how we read the pixels, right? And that's what we upload to the GPU. Yeah. So if we look at that, and I hope I get a ping when chat goes live, or when someone sends a message, because I'm on the phone today. But where is the assets, textures? Oops, there you go. Right. So the only difference is this loop, which we already had going, y and then x. So we're going row by row, right? We now start at the bottom from the last y position, going all the way and including 0. That's one small difference. The rest is mostly the same. One other thing, we just changed this, which is, I think, the internal format. Yes, it is. So how OpenGL is storing the data, because you might have textures or data that is not unsigned byte. It's more than RGBA. Maybe it's an HDR texture. So you're like each component, like the R component, for example, is going to be more than a byte in size. So RGBA does not specify that. Kind of leaves it up to the OpenGL driver. So the better way is actually to specify the size right here. Now, for the other one, which is the format we are uploading, we don't need to specify that because we are actually specifying it here. So we're saying, hey, it's RGBA, and it's like, what's the type? It's a sub. So it's kind of two separate things. For the rest, This is good, right? So that's one small thing I did offline. Now one other thing, but that actually, let me show you guys this. I think that's pretty cool. So if I run, and you get our nice little nMage, sorry, not nMage, nMage. Now I disabled rotation. I can enable it, so now it's just rotate when I click, when I hold the mouse button. You can see now we have like all the 10,000 cubes like before, but you can see my FPS is more than doubled. It used to be 200 or so, 100 something even. Now it's 450. Over double the performance. Why? Well, actually, very simple. We reduce, this is something you'd want to do a lot. We reduce the amount of times we go to the GPU because that's expensive. And for us in Go, it's even more expensive because we have to go through C. So CGO takes a little bit of overhead, and then going from the CPU to the GPU and back, even more overhead. Now, what are we doing in main? So in our render call, let's go to render. We have a loop, and we're doing a ton of, in this case, a ton of GPU calls, right? We are doing set uniform, we're doing draw element, and so on. So we are doing 10,000 draw calls right here. That's already a lot. If we bash this, you can expect, I don't know, potentially also again double the performance. So there is definitely a lot of performance to be had. Here as well. So here is one uniform call, here is another per row, and so on. So this is our hot path right now. Now the problem is before is that these texts. Now usually we would have a system that caches the locations, right? So if we look at this, we get on the spot the uniform location from the string. That's not free. One sec, sorry. Okay. So that is giving us wrong locations. Sorry, not wrong location, but we need to get the location given a name, at least in this kind of setup that we have. So if you just do the call every time, which we used to do, so something like GL get uniform location, that's what we used to do. So every time we call something like this, get uniform loc, we just call this thing, and that has to go to the GPU to get the location back. That's really slow. So I did something very simple, is just cache the values. So if we look at the function now, it's a bit different. What we have is now we have a small hash map for uniforms and attributes, same thing, but I'll just focus on uniform now, where we just have a lookup essentially between, so this is per material, but we have a lookup between uniforms and should actually probably be per shader, but that's okay. For now, it's okay. Between the name, so let's say, what name are we using? Like model mat. So between this and the integer location on the GPU. So when you get this, when you call this, we first do a lookup on the CPU side in the map. It's like, do we have this location? If we have it, we just return. That's it. That's the code path taken in most cases, except the very first time. So in like basically 100% of your cases, this is the code path you're doing. You just do a lookup and you return it. Only if we don't find it do we actually go to the GPU, grab it off the GPU like this, search just to make sure that we have it in this case, and then and then we save it in the map, and then we return. So next time this is called, we can just grab it from here. This is the reason we double the performance, just this. So reducing is essential driver overhead, and in Go we have kind of an additional step where we're doing too many, too much CGO calls, which also has performance implications. So we're just reducing that. Now, for sure, you can reduce it even further, but I think it's a very nice increase already. Right. Now, let's see. So we did this. Oh yeah, so this is a small thing. But if you notice, before our FPS was very, changing all the time, fluctuating, which is normal, but it's not easily readable. So we want something a bit more static. So what we're doing right now is we are averaging the FPS every second. We only update this counter every 1 second to make it a bit more stable. So it stays for a second between, like all the frames in between until 1 second elapses. We essentially average out what was the FPS in all of them. So some fluctuations don't affect us. And if we look at this, maybe set title, yeah. So we accumulate the delta time, right? And because I think 1 over the delta time, that's what we what do you call it? 1 over the delta time, is it? Anyway, so we used to do some calculation, but we did it every single time. Now what we do is we check if so this timer, elapsed time, this is an integer, and ticks per second. So we just get how many seconds have elapsed since the game started, and so this won't give us like 0.5 seconds have elapsed. You either like get 1, 2, 3, 4 like this. So we can check if our last time has changed or not. Have we changed the timer tick up? For last time is 1 and this became 2. That means a second has passed, and so we get the average delta time over all of that time. So we are just accumulating the delta time to see how much change happened. Then we average it out over how many frames we got. So you just get an average delta time, and then we do 1 over that, and that gives us the FPS. That's it. So just kind of a nicer way. I was thinking I'll move this kind of thing into the timing package just to make it easier. Why do that? For now it's here. Like, it's okay. So yeah, let's see. For these kind of things, I was thinking if you guys are interested, we can do extra streams during the week. Maybe. We'll see. Yeah, so some unused variables. Yeah, so let's see. So one other thing is I was thinking about if you're making a game or any projects, you might want to get callbacks from SDL, because right now our callbacks are kind of limited, like, which is fine for a game, right? Like you don't need much more than that. This is kind of okay. But I might want to know, for example, when the window resizes. I might want to know when a keyboard hits them. Who knows? Like we might want more things than the engine cares about. Or just we want to know when something happens, like, oh, the window resizes, which the engine knows about, but it's too much for us to like just do a callback. We don't want to have, to require people to implement 1 billion functions here. But we want to give the ability for those who want to do that. So how do we do that? Well, in the engine class right now, I added a very small thing. On the window, we have a bunch of event callbacks. So the events, like the window events from SDL, they're simply this, right? We loop and we process the events internally. We switch on the event type. Just before processing it, you can give us a function that we'll call. We'll give you a callback and we send you the event. You process it, you're done with it, then we process. If you don't have an event, that's fine. If you don't want any callbacks, but in case you give us 1 or more callbacks, we just call it on those. Maybe I'll not make it an array. I just make it 1. Well, let's see. But that's it. That's the whole thing here. And I'm not sure if there is a function to add callback, or we just make. I think we just we just add it to the array. We just say, hey, here is my callback, and the game will be able to get it right when you get the window. So I think this was pretty cool. Was useful. Might show off a small project I was playing around using nMage. But yeah, let's see what more. Sorry, there's bits more than I expected that I actually did. But they're not big things, you know, small things here and there. Small things. Okay. On chat. Okay. All good. Now, set font. So I realized we don't have a way for people to set fonts in an easy way in IMGUI. Like I want to abstract it a bit more. So here, not here. In the UI IMGUI, we just have a set font. Is it here? Wait, where is the set font? Is it in the engine? Fonts, no. Oh, okay. Add font TTF. All right, there we go. So, we just have this function. It gives us the TTF font, the font size, config if you want. These are optional. That's why I made the pointers. So if you don't pass anything, we just default them. And then we do all of this. We rebuild the font, we re-upload to the GPU and so on. So you don't have to deal with this mess. So now it's very nice. If you want a new font, very straightforward, right? And we return the font just in case you want to do something with it, because sometimes, you know, there are functions here you might use. And, you know, some configuration. And right now I just like to make the things public. There is no reason to make them private. So like these IDs were just made public, just in case someone would like to, you know, poke around in the on the memory. I think it's always a good idea to give people the flexibility if it's not something extremely dangerous. Like sometimes, which is I think very rare, a bunch of things must happen, absolutely must happen when something changes, for example. Or it's an API that's very easy to mess up. In that case, you might make something private and then give functions to deal with it, which is okay. But in general, that's not the case. And we don't want to limit people by saying, oh, we don't provide that API, sorry, not doable. Instead, we say, here are the APIs that are easy that we have. If you want something more, well, everything is exposed to you, go crazy. Right? And that's one of the best things you can have, is just to have a good, stable foundation that you can build on or completely change if you really want, without someone for no reason blocking your way. So I just said, all right, let's make this public. Delta time, yeah. So this was a funny one. It was here, right? Yeah. So I think this was really old in one of the first days of working on this together. We used some code with a timer and things like that. Anyway, we are passing it some wrong stuff. Like we're passing it, I think, some milliseconds or something, because here alt wants delta time. Time elapsed since the last frame in seconds. It's a delta time, essentially. It just wants a delta time. And we're doing all these calculations and using SDL, and we already have now a timing package. And the effect of that was, if this was too fast, IMGUI would go crazy. Like it would go extremely quick. That's how fast it would go. Like you just want to move something a little bit, or you input something into text field and it repeats it like 10 times because the delta time is wrong. So now like I removed all that extra craft. It's much simpler, much faster even. All we do is like, here's the delta time, enjoy, right? Delta time is never 0, so I fixed that. That was a crash, I think, in IMGUI. Is the delta time can sometimes, if you're running at super high frame rates, maybe in a test scene or something, or in a really tiny game, your frame rate is so high that this thing, you know, when we convert to float 32, because it gives us a float 64, so you might have like God knows how many zeros and then some numbers, and then when we convert to float 32, all we are left with are zeros. So delta time is 0 because it's so small, it goes to 0. So all I did is like, hey, you know, delta time If it's 0, we'll just make it a microsecond. Like we'll make something really tiny, but at least it's not 0, so no one explodes if they try to divide by it or do anything with it. That was one funny thing to do. Then files, nothing. Debug mode by default. So when we wanted to run with asserts on, we needed to do like go run --tags debug, right? But that's kind of like the thing you want to do most of the time is debug, and only like once in a while do you make a release. So by default, I changed it to debug mode on the asserts. So not here. Let's look at consts. Why do we have those? Okay. So I made the flag release instead of debug. So if it's release, we have debug false. If it's not release, then we have debug true. And by default, it's not release, right? If you just do go run, then you don't have any. So that's good. Why did we scroll down? Okay. Anything else? Wait, what happened here? Okay, so that's it. DT is never 0. And we are done. Right? So these are the updates. Sorry it took this long. But now we can start. Let's just try to do something today. Let's look at our to-do. This is by no means a complete to-do. But yeah. So, I mean, rendering system is kind of one thing for sure. And the material system is kind of awkward. So one thing is this, bunch of texture IDs don't make any sense, because like, which texture is this? Right now we hard-coded them to match the shaders. Where are they? Oh, not here. The resources, shader. So if we look at like our fragment shader here. This vertex, yeah. Wait, where is the, oh, there we go. So we're assuming like, okay, this is the sampler, it's sampler 0, and then the next texture goes in the next slot and things like that. I don't think I want that, to be honest. It should be, you know, here is our material. Here are the fields, like here's the diffuse texture, here is the whatever texture, and you say, you know, put this texture there. So instead of this, might make sense to, you know, set them individually, maybe. So we like have a bunch of fields that get bound. Perhaps, right? Like set text. Is it add texture? I think. So let's see how we read it right now. Set texture on material. Okay, there we go. Add texture ID. So we're just getting textures of the mesh, like the textures we read of the mesh. Wait, no. We read the mesh, then we read the textures independently, and then we add them to the mesh. Now I don't know why do we have the textures on the mesh itself. I don't think this makes sense, to be honest. Yeah. So like, should we remove textures from here? Texture IDs from here? Probably. But same way is kind of tired today. Same way is that we want to specify something like simple math dot, for example, diffuse texture, right, equals something. That's what we want to do. And then to bind them, we can just make a bunch of calls. Bind, bind, bind. Or even just bind all textures and just binds everything. So let's do that actually. We can change it. For now, we just have a diffuse texture, UN32, which you can set. And then when we bind, we don't do all of this. We need to specify this thing. Well. I think I don't want to make it messy. That's the thing. So like, which texture do you bind to? We can store this information here. I mean, we can specify that, for example, diffuse texture is always texture 0, that texture is some texture 1, and so on. That could work. So use program, active texture, so 0, and then we bind m.diffuse. Right? And we don't want this. We don't want these. We don't need any of this. Texture ID. Don't need these. And bind. I mean, yeah. What's the max texture? Let's see. I mean, I don't think this makes sense. We just use program 0. I don't think I need any of this. Right. Maybe use program 0. I'm not sure. Well, for now we have one. Let's unbind. Or does it unbind them all? Is it independent? Maybe. So to do, should we unbind textures here? For example, should we do this? Are these two lines needed? But I think this gives us kind of a better API than honestly the mess we had before. Who's sad? Someone's sad. Add texture ID. You go by Y. These we should remove for now, I think, unless I missed something. Doesn't seem to be used. Okay, we need it. We can re-add it. For now, this makes a lot of sense. So we just set the diffuse on the material and configure material, right? We set the diffuse and then later on we bind and everything should look the same. But I hope a better API. Yep, we have our textures, they look nice, they look correct. That's that. Okay, so this is better. Now, the thing that we don't have with this kind of setup is like a generic material system where we can say, hey, this shader actually reads out, maybe it has X field and we want to see it in the UI and we want to set it, something like that. How do we do that, right? Like we want to read the shader, extract all the kind of fields in the shader, and then kind of on the fly know these fields and allow the user to set them, maybe through reflection or something. That's kind of in the editor thing. And then when you bind, you bind just like we did now. You just bind all of them. But I'll set that for now to be low priority. What we want to do is like material system editor with fields automatically extracted from the shader. I think so. I do think so. But yeah, now I think let's make this our goal today. Have something better for rendering, because we don't want our users, hopefully, to come in and go do something like let's see, like a draw call like this, draw elements, have to deal GL or something else directly. Hopefully not, or minimize that. We want to get rid of these. So we want a system where we get like, here is the material, here is the object, take all of them, draw them. I don't care how you deal with it. You want to batch it, you want to do some magic, but from our side, it's like, here's the material, here's the position of the object, here's the object itself, like the mesh, and that's that. I'm not sure what the calls would be, but I think that's it. And another thing is this. This is unfortunate, but it is the requirement, it seems so far, which is OpenGL has some information that it stores on the thread. So on the OS thread, there's like some variables that are different, and if you switch threads, it's going to lose those variables, and that won't work. Like, we'll get problems. So what we need to do is we need to make sure that when we create OpenGL, it remains on the same, like all the draw calls, everything we do is done on the same thread it was created on, right? And that means that even if our game is running in parallel, maybe some of our logic is running in parallel, all these nice things, when the time comes to draw, it needs to go back to the original thread. We need to send that data like to that thread. It's like, here is the thing, draw it, right? And we don't want our users to care about this kind of thing. So I'm thinking the engine does that. When you do like, I don't know, engine init or something, engine init, which inits SDL, it just remains there. Now, I think it's not actually a problem until you call create window, because that's the point where we init OpenGL. We create a context, which makes it current, and then we start doing OpenGL calls. No OpenGL calls before that. So perhaps, yeah, this magic. So we want a function that has like, so we want a renderer for sure. Do we have a renderer? No, we don't. We don't. Later on, it should be, hopefully, at least later, flexible to handle something other than OpenGL. For now, it's okay. So like, renderer is a hard name. Okay. So what does renderer have? Let's do like renderer. Maybe it's even an interface. Let's make it. And we just have like submit. Submit. Maybe just call draw. Maybe submit is more accurate. Yeah. So essentially what we want to do is we'll have a system similar to how IMGUI works with us. So IMGUI doesn't render, right? We tell here's the UI we want to do, and it sets up all the vertices, all the indices, things like that. So it sets up the buffers for us, and it just gives us the data. It doesn't care how we draw it. Doesn't care if we are, I don't know, on Vulkan or OpenGL or DirectX or something. It's just like, here's the data. I don't know, you draw it, but we give you the data. We submitted a list of things to do, and this is this loop here. This is the command list. It gives us a bunch of data that we loop over, and what do you call it? Then we go in, we get some vertex buffers, we bind them, we do all of this magic, and we actually draw. We draw, right? It doesn't draw. The idea is similar in this case. It's like the game at some point starts submitting things to draw. It's like, here is the thing, please draw this, please draw this cube for me, please draw this and that, and it does the rest. It binds the shaders, maybe it does some, these things can come at different times, so it should, I think, handle being called in parallel. We essentially add them all to a big list. Maybe we do some, sorting or filtering or anything. And in the end, we get some amount of those and we draw them. So, yeah, I don't know if draw is a good thing, but I'll keep it for now. So let's look. So we need to deal with this guy. What I would like to do is, starting now, maybe when you create a window, is it on the window or on the engine? It could be on the engine. I don't think we support multiple windows, to be honest. Just doesn't make too much sense, complicates everything. Yeah, I think we will not for now. So the engine is going to create kind of a separate Go routine, right? Look that and have the like OpenGL created on it. I mean, it could be on the window. I don't know if that makes sense. Like window draw. Window can have a renderer. I'm not sure. Kind of confused. So this guy needs to be called and maintained somewhere in OpenGL. And every GL call needs to happen there going forward. Yeah, I mean, we can, instead of being in the window, we can do this just as startup, and we only ever have one window. So we don't have, so GL init happens once. When OpenGL context. I mean, this is for the window on Windows. You must re-init if switching between GL contexts. Okay. Yeah. Okay. So you do need to re-init. So I think it might make sense then to do it on the window. And the window can get a renderer attached to it. That might make sense. A renderer is just an interface that we have. So we'll do like, let's call it. Can we do numbers first? 3D. 3D render. Kind of long. let's see, what do we call this? So we want like a default renderer that one will use. 3D rend. I hope it allows us to do that. 3D rend should go. Yeah, it doesn't like numbers in the beginning. Okay, just do renderer 3D, rend 3D, and it's going to be a struct rend 3D, and this struct is going to implement essentially, so like var rend 3D equals renderer equals rend 3D, right? So this is just a nice way of making sure a struct that you have implements an interface at compile time, because this thing is not going to create any real memory, it's not going to do anything, but because we have assigned it to like you know, an unused variable here, underscore won't have any, it's not a real variable, we're throwing it away, but it still does try to do this. And so if this fails, it's completely, you know, it's directly obvious, and here it will tell us, oh, you know, missing method draw, it doesn't implement the interface. So if we change the struct by mistake or we update the interface, we'll immediately know like, oh, we need to go and update this, right? So we don't fail at runtime, we fail at compile time. So now let's look at what we actually do in our render loop. We'll figure out the runtime block later. I just want to know here. So we need a material, we need a mesh to draw, and we need where to draw. That's it. We bind and we went our way. Sounds simple enough. So let's take that. So in the material, so we need a mesh m, which is like mesh. Should we take a pointer? Should we take a pointer? Maybe. We'll do for now. We need a mesh. We need a mat. Materials. Material. And well, I like to put this here. We need a position. So we need kind of the transform where to draw the mesh, which is this boy. Not the fastest way, I think. But yeah, transformation mats. Which is GGLM, you know, this guy. That should be it. You give us the information, we draw for you. All right. So R3D, rend 3D, draw, draw these, please. Now it's happy. Now this guy is not giving us an error because it knows we implement the interface. Cool. So now we steal all this code. Where's our renderer? Because you do not learn OpenGL, you memorize it. You don't even memorize it, too hard. Don't try. Yeah. All right. Material. Oops. Yeah, let's do it in order. Mesh.bind. These. Okay. Mesh. Buffer.bind. Material. Oh, this is 4.1 core, right? Yes. Let's make sure. Mesh buffer bind, material.bind, and we don't really need to unbind because next time we bind, it's going to override anyway, so that's fine. And then we set this guy trmat. I hope Mr. Visual Studio doesn't crash on me again. Every time we make a file, this happens. Such a mess. That's why it will make sense what I'm doing next. Project I'll show in a bit, maybe today. But yeah. Why are you sad, Mr. .buff? Yes. Material.bind, yes. And then set uniform for blah blah, that's good. And then GL draw elements with the mesh and GL. Good, that's it. That's really it. That's our entire draw call. It's not much more to that. Now, one thing you could do, for example, is if this ends up today, man, you're saving file. Anyway, if for example, like let's look at here, these are all going now. If we want to draw 10,000 cubes, we're going to what? We're going to bind the material 10,000 times. We're going to bind the mesh 10,000 times. We're going to draw 10,000 times, and of course set the material. But if you look at what we're doing here, like that doesn't make sense, or is not needed at least, because they all use the same mesh data and the same material. So we really only need to bind them once. So here we are kind of doing some kind of batching, where imagine you have a big game, and you know, all kinds of objects, all kinds of materials on the objects, things like that. Now, you want to minimize the number of draw calls, not just draw calls, the numbers of times you have to go to the GPU, do something with the GPU, because that's really slow. And if you have a large game, that just takes it all. Like you saw how removing these function calls just to look up the location. We're still setting the data, we're still setting the uniform, but just looking up that more than double the performance. So it can have a really big impact. So what you do is we sort in a way all of our things that we want to draw. We don't draw immediately. We can add everything to a big list, and then when the time comes, we find all the ones that use the same material. We bind the material only one time, and then we draw all of these objects, right? And potentially you say, well, find me all the ones with the same material, and then using that material, find the ones with the same mesh, bind the material one time, bind the mesh one time, issue all the draw calls with the different, with the different transformations. That's it, right? So it can make a lot of sense to do that. And I guess we will see a bit of the effect that it has, because right now we're not caching. We even if the mesh is already bound, material is already bound, we will still bind it. This, you have to do this. This is one of the things that you only have to do if the translation changed. The same model matrix, why do you update it? No need, right? And then draw elements, right? Yeah. So let's see. Let's run this boy. Now, obviously, here we're doing GL call, so this needs to happen within the same GL context, and therefore, what I want to do, how are we going to do this? For now, at least I just try. Let's do a renderer. It's all like single threaded. Var R3D. Oh, yeah, we should change the name. R3D. This is what? A renderer or on, yes. Dot renderer equals rend3d dot this guy, right? So we have this interface now. Now, instead of all of this mess, what we can do is issue a draw call. It is our material, our mesh. And here is our material, simple material. And here is, what are we using in this case? This guy. And why are you sad? Oh, there. There we go. So this we can change. Oh, actually. So every time we translate this guy, and then we draw, and then every time here, we translate differently. And we draw. This we can do, sure. And I mean, I don't think we need to issue a call here. Maybe that's it. Let's open the explodes. Oh wow! For once, we did something that doesn't completely explode, and it rotates. Nice. You can see the FPS went to crap. 60 from 400. This just shows you the importance of really reducing the amount of GPU calls we do. Has a huge impact. So yeah, so we're barely catching up, like keeping up. Very bad. Yeah, so you can see it's very bad, it's very slow, and it's really this. One thing we can do for now, right, is we can check. Okay, I'm not sure if Go can check pointers. Can we do mesh? Yeah, it seems we can, hopefully. So like last use mesh, like let's just say bound mesh, right? Let's store the mesh, and let's store bound material. I mean, they could have changed. Yeah, I mean, they could have changed. Let's see. For now, assume they won't change. Materials of material, right? So you say if mesh is not equal, then this guy equals mesh, So we're going to bind it. If it's not bound already, we will bind it. But if it's bound, like, no need to do anything. And then same thing for the material. Bound material. Sorry. If mat dot bind. Too tired today. Mat equals or doesn't equal the bound material, then material, and oops, there we go. This we set every time. Now at least now this is not really a way, like, because if you have a large game, different objects, you might be able to do this optimization, but you have to kind of order your things first, which we completely not doing right now. But for now it's okay. All right, like for now we have simple cases, even a bit of performance is fine. We should be back. Yes, we're completely back. So right now somehow the performance increased. Could be just fluctuations, but yeah, it increased a little bit, like 20 FPS. That's something. Yeah, we have this. Very nice. I don't know why it's increased. Excuse me. So yeah, so we just kind of reduce all of this. This guy, this guy is not needed, this guy is not needed. Just to make sure again, you know, that we have correct behavior. If we zoom in, we rotate, everything's fine. FPS is good. Yeah. So yeah, we're on the same FPS now. So just saving like these calls adds up a lot, really a lot. So yeah, that's part of it. We have some renderer. Now, I'm not sure what the best way to do it is. What I would like to do is like maybe have everything in a buffer. So when you submit, we don't draw immediately, maybe. Or we draw in parallel to what we are doing. Yeah. Because if we just keep like add everything in a big array and then we draw them later, like what if you change something? You draw one thing with one texture and then later on you set a different texture. In that case, you know, we'll have to kind of bind or like copy this, but then what about your uniforms? So I don't think it's safe, at least not with the setup. We shouldn't. So that's okay. Yeah, material. Okay, and the binding the buffer is just the VAO. So only 2 calls, but they're still doing a huge effect on this leg. Yeah. Okay. Now that we have this with some caching here and there, let's figure out this mess called renderer. So maybe have the renderer on the context. I think that would make sense. So, where is the window? Window. So we have a window class. It has currently the GL context, which is set right here, right? When we create the context in init OpenGL. So this is OpenGL stuff. Instead, by the way, let's call this like this is a GL renderer, just to be safe. Okay. Run 3D, run 3D, run 3D. Where is that? Import as run 3D, what? Oh. Okay. Oh, it's been an hour already. Crazy. All right, so I believe, let's put these things on the renderer. So all of this OpenGL magic, SDL window, create contexts. And make it current. Problem is even this must. Let's see, where is this guy? I want to know, is it just the GL? Well, I mean, I think the context as well. Okay. Not that. Copy. Thank you. Window to associate to the context. Make current. Yeah, it must be called in the presence of an active GL context. Init loads pointers. So yeah, I think then the renderer, perhaps, like func new rend 3D GL, right? So we can do the init there, but we can give it perhaps like a window, or really just a GL context, SDL.GL context. Yeah, what's that? Yeah, it's just a pointer. Right, so let's take GL CTX, that's an SDL GL text. So you give us this, and then we can current thread ID. Honestly, we'll just take the class window is a engine dot, just to be safe, so you can have full capabilities. And you can store reference to it, I guess. Oh, but this will be circular references, right? Or not? No, that's why we made an interface, so it won't be circular. Because we'll always be passing and dealing with the interface. These things hopefully will not matter. Main will call them, I think. Yeah. Okay. So SDL currents, window, SDL window currents. make current, right? So you say, well, we'll make it current just to be safe. Error, you know. And error. So in this case, this. Then we re-init OpenGL, right? Because that's what they tell us to do. Is you should re-init every time you switch context. That's what we're doing. We're switching context, and if you have one window, it won't be a switch, but you know, we'll do it just to be safe. Again, we'll do this here. Now, now my question is this thread thread stuff. So loc os thread OpenGL. Yeah, I think actually they have an example doing this. So SDL Go. Examples. I think they do. Render coroutines, render queue. SDL.do. What's that? Well, so they run this. Defer destroy. So they're doing all the things in SDL do. I'm assuming this runs it always on the specific thread. That's kind of annoying. Yeah, any call they're doing for graphics, they're doing inside SDL. SDL do. We don't want that. SDL do. In the main thread, okay. SDL main. Okay, again, they're doing do and whatnot. Line. Where's the queue? I don't see anything. Well, anyway. I mean, well, essentially, I have to do something similar to SDL do and SDL main. because either we keep rendering, so we set up all of this on the main thread like we are doing now, and then we can run the game logic and the engine loop in a separate thread, and then when you render, it actually goes back to the main thread. That's one thing. Or the other way around, right? Is that we set up the renderer on a separate thread and we lock, so we have two locked threads, or just one, just the renderer thread, and then the main functions happen there. I'm not sure. Hopefully nothing explodes. I guess we'll see. One way to know in these cases. I just wanted to avoid wrapping everything like they have like SDL.main, SDL.do, where every single time you want to do something, you have to do SDL.do. At the very least, we want to hide off that mess. Let's see, SDL.do. Let's see what it does. Call in main. Right. Yeah, so you can see on init, they just lock. Call queue. Okay, call in main. They just have a queue where they call the function and then they say, oh, we're done. Yeah, and then they run this guy. Call in main. Yeah. Yep. Call in main just takes a function. Says here's the function, and then it makes a channel, calls it. Once it's done, it returns. Yeah, very simple. The idea, the main thing they did is just on init, they lock the thread. Yep. The main go routine is bound to the main thread, yeah. And the rest go wherever they want to go. Okay, so for us, excuse me. So how do we want to do this? I mean, we can leave it as is for now, not multi-thread, and then figure this out later. It's just not connected. I don't like it for now because the window is separate from the renderer, and it's just all over the place. But you can take this. Or we can just embed this in the window and make sure the window calls it on the main thread. Oh yeah, that might make sense. So wherever you call on it, maybe you say like init is wherever you want. Done. How? Just trying to think about this. I mean, yeah, we can maybe keep everything as is now. Just thinking who locked on init locks. Like here, we can do lock. What? lock or runtime. So in here, so if you call this from your main thread, we will lock that. Whatever you do, we lock. Then we start the engine. Then you do all of this magic, and we can the window can have a renderer. I'm not going to renderer, just a renderer. Right. And you can just do window.rend and call. Yeah, create OpenGL window, create OpenGL window centered. So in all these cases, we'll now start taking a renderer, is this boy. Like this, and this guy, let's just clean it up. Renderer is Mr. Rend. And that's it. And the renderer doesn't need to do anything with the window, doesn't care. Let's give this function in case in the future this becomes like needs actual setup. So just give a function, or no, it doesn't. This can go away, and yeah. So we have the window, we give it a renderer to use, and then it does all of this. The engine, now the engine internally can be multi-threaded, or does a coroutine started off from an OS thread run or not? The calling coroutine, why is the calling coroutine to, yeah, so it just like keeps the coroutine. So if you're on the main coroutine, just keeps it on the same system thread, never moves it around, because by default Go would just move things around. That can break steal and things like that in that thread, and no other coroutine will execute in it. And look, the thread will be terminated on the startup thread. Should call this, right? So we have this, and no other coroutine will run on that thread. So that assumes, that means if we run another coroutine, that will be on a different thread. Yeah, now remember, you localhost thread guarantees that only one coroutine ever will be running on that thread. So we essentially have just normal threading. I mean, the nice thing about Go is or one of the features at least, is that they let you not care about threads. You just say, here's a coroutine, and Go takes care of like, are these two coroutines on the same thread? Are they on actual separate threads? But and you have no control otherwise. But with localOS thread, we essentially get the, we get the ability to do things normally. So with this setup, the main engine and the rendering loop will be, because if we like, we'll call from the main function in our main, or is main. So the first thing we do is engine init. So that's main is running on the main thread. So the main thread will be locked alone, right? That's where our rendering will happen. Now, we can, for example, we'll get the calls from the main thread. So like engine.get window, update, whatever, all these things will be called on the main thread. But within we can do whatever we want. So we can have like a separate thread for the game to run in or something like this. We can think about it's not really hard right now, I don't think, but let's say better multi-threading. What that means is to be decided. At the very least, let's do this. So yeah. So now I assume even if we call the render stuff from another Go routine, it will go back, I think, to running on the original one. I'm not sure. Or it might not actually. And that's why I think we need a closure. We need a system just like STL did actually. Then we can actually multi-thread the renderer, or like the whole engine. Like we can have multi-threading, at least on the rendering part here. Anyway, let's do this now. So this guy wants a renderer now, and we can just do this. 3D, we don't need this anymore. And here we can just do window dot renderer. Same thing. Should all be the same. Are you the same? Yes, you are. Thank you so much. Okay. So now at startup, the user doesn't need, so I'm just trying to make it as simple a framework as we can, so people can just focus on making a game. So we just init, that looks a thread, so now this main thread is now its own separate thing, this Go routine is its own separate thread. The engine, everything now is running on that thread. But if I think we go to, by the way, do we do any GL calls now? GL dots? No, that's perfect. Well, I don't want GL stuff directly here. In our draw, let's just imagine we do this in a Go routine. We just wrap the whole thing. That's it. And we'll even wait for it, like wait group sync.wait group let's add one. Here we sorry, done. And here we wait, right? So we write somewhere and here we wait. Hopefully it actually runs. I don't know if it locks it up. Yep, we locked everything. Actually, well, let's see. And this is not just a lock. I think this is essentially us crashing. Yeah, you can see GL use program completely exploded here. You get a bunch of registers and whatnot. Okay. Locked to thread runtime acquire. Oh. So this is kind of our multi-threading problem. So what needs to happen is when we do draw, it needs to happen on that old same thread, because now it's happening in the Go routine, not on the draw thread. So to do that, we need this guy to essentially have something like SDL. So we'll do like, let's just check SDL do or SDL main. Starts an actual main, I guess. Wait, where is this guy? Oh, okay. So it just takes a function and let's see, where does it call it? Colon main is a closure. That takes this guy and runs this guy. In the main thread. Yeah. So we actually got a use for this then. Let's do a similar structure. I think I like it. So thread closure. We'll figure out the name later, but all it is it's a function that call queue. Oh, it just sends stuff to the queue. That's a function. So like we'll have a draw queue. I'm not sure because I think I read some issues with coroutines. Sorry, not coroutines, but with channels and localOS thread and things like that. But let's see for now. So draw queue, what's that? That's a channel of functions, perhaps, to run. Not sure. We might want to keep this for later, honestly. Just a channel of functions and I don't know. Draw queue, make channel, and then in here. I am not sure. I mean, let's not do this now. Anyway, we'll probably make time for that to multi-thread. Multi-threading is something different than abstracting part of the renderer out, or even making some kind of renderer. So this is a good start, I guess, for renderer. This we don't need. So we'll assume, because that's what we want to do actually in the first place, is rendering and the main engine loop will happen on the main thread. What you can do is, for example, potentially you can run your game logic, at least parts of your game logic in parallel, since that doesn't touch the rendering. And then like when you come to the renderer step, then you wait for all these parts to finish and you take all of them and you send them to the main thread for rendering. Now physics, I believe we can also, because that can run maybe before the frame. So that can run in parallel. So a bunch of things can be parallelized and then we kind of bring them together to be rendered on a single thread, which is our main thread in this case. And I think it just makes things simpler for now. But yeah, so we'll not even say better multi-threading. Multi-thread the engine. Or we can ask a question for now, is should we separate engine loop from rendering loop? Or do we leave that up to the user? Or leave it to the user? If we leave it to the user, more or less, at least like we just say, hey, run this in a coroutine, or we call them, like we call some functions in a coroutine itself. So you say, oh, you know, we are calling your update function. This is actually a coroutine. Go crazy. And I don't think it makes a lot of sense. So you leave it up to them. You want to multi-thread parts of your logic that, you know, separate. You want to do things up to you. But in the end, by the time, you know, you must wait for this to finish, all of them. So when you reach render, you're good to go. Yeah, let's just make sure we didn't break anything. I mean, we didn't do much. But yeah. Okay, FPS still going good. It increased again. Why? I have no idea why that happened. Absolutely no idea. Oops, too far away. So you can see we have a ton of them. They're all being rendered. So that's another thing, is custom culling. Things outside of our direct view, like why are we even drawing them? Right now they are being drawn. We don't see them when they are being drawn. So that's definitely one thing. Wow. Yep. Anyway, that's for a later time. We can add it. Custom culling. Abstract UI. We actually did that, kind of, right? The abstract and GUI rendering setup we have. At least we have a basic one. So all of this magic is now simplified. Our renderer. Oh, it doesn't even need these. You don't need to bind anything. We just do basically our logic, like, oh, I'll move my stuff around and draw and things like that. Right now, you know, this is kind of, is not how it would happen in Unity. In Unity, you'd have like 10,000 objects, unless you are instancing something on the GPU, but like you'll have different objects. But here we're doing something like instancing, where we have one thing and we move it around. We draw it many times. But anyway, that's fine. This I would really like to move, because I hate these variables being here. Let's do that, actually. Timing and, you know, FPS calculator bars. Okay, and what do we do? So what we're doing right now is render. So I think then it doesn't matter. Frame end, frame start. I mean, we can put in frame end. This after rendering loop is essentially frame end for us. So in frame ended, before we calculate the DT, or after, before we update DT, it accumulates essentially the old delta time, FPS stuff, that's not here, that's just that, and yeah. Average FPS is what? Flow 32. just init to 1, so no one divides by 0 or anything. Func gets average FPS, return average FPS, returns the FPS averaged over 1 second. Okay, this guy, wait, where is this guy coming from? Oh, average FPS equals 1 over. Okay, then we reset these things and calculate new DT. Right, with this, we can do, there should be, I think, a small difference. But yeah, like let's do timing dot get average FPS. I want to check check them against each other just to make sure. Ooh, why did we crash? Why did we crash? Why are you sad? That's delta time. I think this guy is like dividing by 0. Okay. No. Okay. Time to debug. Do we ever get here? Let's see. For some reason, the debugger always takes ages to run, while everything else is very fast. For some reason. I am not sure what the problem is. Get average FPS. Delta time, which potentially is small, sure. And then elapsed time, which would sometimes be 0. Last elapsed time. Okay. So just to make sure, I'm assuming after this line. No, it's actually not. So where do we crash? GL swap, frame end, update, clear, render. Oh, and draw. Okay, now we have some call log. And during external code execution. So this sounds to me like we're not locking the main thread. Okay, so this needs to happen in func init. So it should have, but I'm not sure. Let's see. No, that's okay. We're already calling. So do we have any Go routine? Go. No, we don't. Go. So it ran like in the rendering loop, it crashed. after a frame or two, while things were still happening, potentially, completely exploded. Even though we didn't do anything special here, I am not sure. So we do like 1 frame, okay, 2 frames, second frame crashes because the first frame is still running somehow. One frame, then the second frame we crash at draw. Let's go again. 1 frame, second frame, let's go into draw. We don't bind anything because we have them. Set uniform works correctly. Mesh, buffer, buff index count, obviously, right? And then what is happening, people? Does this really need to be here in main? Should be the same coroutine, shouldn't matter. Unless I misunderstand something. No, not really. What? I don't get it. We didn't really do anything. Is this guy somehow... Because it worked before. So let's say, you know, I put this back, it shouldn't matter, and I comment this out, same thing. Oh, it still crashes. What? What is going on? Well, the only other difference is really this guy. And average DT and all of that. All of these can go. This is exactly how it was, which was working. Now it's not. Did I miss something? Go routine somewhere when I was playing with it. No. It's all the same. Well, you say, all right, let's bring it completely back to how it was, which is 1 runtime lock here. And then we init and everything. Okay, this doesn't make any sense. This is completely off. Someone has ideas? Interesting. Oh, we did change one other thing, is the bind here. Are we unbinding somewhere? I think we are. We potentially are. So let's do cube mesh, bind, material, simple material. Oh wow, yeah. Okay. So somewhere we're magically unbind. Do we have unbind? I have no idea. Unbind, bind. What? Ready? There's no bind at all. Well, that's interesting. Let's just do this for now, and then we'll fix this boy. Oops. This guy can go back, link here. So now this will crash. Okay, and this. So on the renderer, let's add another requirement, which is we want to do frame end ended to end. So you can see we got an error because we don't implement that. So we say method r3d frame end. All I'll do is I will nullify excuse me. I'll nullify the bound mesh, right? Oh, okay, that's fine. So what this will do is essentially we reinforce a bind every frame. So when we swap the, I'm not sure if swapping the buffers kind of unbinds anything. I honestly am not sure. We might want to check. Oh man, just save please. Wow, man, bound mesh. Now in the engine somehow. Where's the engine loop? Game. Yeah, so in here, when the game frame ends, we can w.renderer.frameend. Right. Let's call this. Now it shouldn't crash. Yes, because now we nullify, so we force a rebind next time at the first time this shader and like mesh are used next frame, and so we maintain our promise. So only the first time we take a hit, and then all is good. Okay, cool. That's that. We have this now. We have these. All is good. Let's put this guy here. And I think that's it. Oh yeah, so we wanted to check our FPS stuff through saying something timing .get average FPS. I need to say FPS. It should approximately match. It's delayed by 1 frame. It's funny. Oh yeah. There. Okay, so it's accurate. 1 frame delay. Let's why though? Okay, so let's move this in frame starts. Just cache this. We use it multiple times. They're a bit different, but they match more or less. Yeah. Cool. So I think this is good. Is good enough. So now we can get rid of this entire mess by just putting here timing dot get average FPS, and we don't need all of this, we don't need this. I'll just update the view every second. Yeah, so we don't need to do elapsed, do we? Maybe we keep it, I guess. Yeah. So we keep it averaged. Get rid of these, get rid of all of these. Finally, now I'm happy. So we just show it every frame, but in reality, it will only update once a second because the timing package is only updating once a second. We are updating every frame though. I like how we dropped a bunch of FPS just by updating the title too much. That's fine. That is okay. Yeah, I would like to just check. Yeah, are we going to get around 10 FPS more? I mean, at these high FPSs, any small changes will change things. Not really. It's all the same. Anyway, so that's fine. I think this is some good progress for today. We have 0 OpenGL calls in our main function. Our game has no idea about all of this, doesn't care, and hopefully, you know, we maintain this going forward. If you want, you should be able to, and that's the point. But if you don't want to, you know, then you should just be able to say, hey, create this object, put it there, and things automatically happen for you. One thing we need to work on, like a scene graph, that's like when we start working on it. We also need, I'm saying low priority just to mean, you know, later actually audio, I would say it's, yeah, needs research. But like low priority just means like maybe not now. And things up are like, hey, I would like to do this soon. So like renderer, batching. So batching is like what we did here. Now this is a best case scenario because we only have one mesh and one mat. But if we have even if we have 2 of them, but they're all mixed. So one time we get a call for this, one time call for the other one, then we keep binding and rebinding all the time. And that's really, really slow. Especially I think when you're binding materials a lot, that's kind of disastrous. So you want to kind of order them if you can. But yeah. Yeah, maybe later as like entities components. There are a bunch of libraries for this. I would like to explore this, but I was thinking maybe we wait until generics is implemented in Go. Yeah, we'll see, I guess. Camera on my to-do though is simple game. Oh, and we do need to integrate physics, but this is a big project. Like it's going to probably take a long while to do, but that's one thing we need. And then because I think the physics system is kind of mature now, like I mean the C wrapper for it is mature, the Go wrapper is mature to some extent. Like it has the fundamental features, like collision detection, raycast, things like that. All of that's done. And so if we can get that in, then we can get some nice collisions, but we can do some simple things before that, right? I think next time we can actually start looking at the simple game, right? So that's around 2 hours. All good. I think it's a good starting point for today. Thank you all for coming, and see you next week.